This video, I'm going to try and deconstruct some of the idea about adjusting means in analysis of covariance. To situate you, especially those in my class, this is from our Introductory to Analysis of Covariance, Chapter 4 or 14, depending which textbook you're using. That's our Lomax and Housefall textbook. They have an example about graphs of ANCOVA and adjustments, figure 14.1 or 4.1, again, depending which textbook you're using. So I like to use this as an example since we've already used this maybe a little in class, but definitely have used it, have seen this in our textbook. So what are we looking at? Let me first highlight this equation I mentioned in a previous video. I go over it shortly because talking to it really without an example is very difficult. So first, let's define a couple of these things. That y prime there, that is our adjusted mean. So this value, this y bar prime dot j, this is our adjusted mean. And the way we adjust it is, guess what? We take the old mean and we subtract something. What we're subtracting is some difference on the covariates, and we're accounting for that by using weighting that basically by using the slope. So b is going to be a slope, and this here is the covariate, is the observed score in our covariates. So we have a mean for a covariate, and we also have a grand mean for a covariate. Over on the left-hand side, I denote a couple things. This is going to be the slope, so 0 is the slope right now. These are all intended to be y bars, that is, or x bars. They're intended to be means. So this is the mean of group 1 and the mean of group 2 on the outcome measure. That should read outcome here. And the next one is the mean of the covariate on group 1 and the mean of the covariate on group 2. This is the grand mean. These two are symbolic of our adjusted mean of group 1 and adjusted mean of group 2. So I just wanted to set you up. We're using this equation. So let's take a peek at what we have here. We have we have y1 for group 1 is 50 and y for group 2 is 30. And we can see down here, I highlighted those in black as a circle. Our mean of group 1 is 50 and our mean of group 2 is 30. Notice that the slope adjustment is 0. That means the amount of adjustment we're going to attribute for our covariate is 0. There is no impact here. In your textbook, the example uses 1. So let's see what happens to those red and blue dots, the red and blue squares here. One is a diamond shape and the other one is a square. Let's see what happens when we do like your textbook and we put a value of 1 in for the slope. We can see that there is an adjustment. We can see that in this at this time, with an adjustment starting with 50, we have adjust, the slope is 1, we have adjust based on our model, x1 is 20, and the grand mean is 15, so we've actually ended up removing about 5 points, not exactly 5 points of effect from a model. So that means that we have gone from 50 down to 45. Now the opposite is true here. The covariate x2 goes from 10 to 15. That is, the effect of being an x2 is 5 points away from the grand mean of the covariates. Another way of saying this is that we're going to adjust, because of the covariate, we're going to adjust our outcome measure by positive 5 points. And here's our little code for that. So we can see that when we have no effect of our covariate, as there is no relation of our covariate to our dependent variable, we have no change. But when we have a very strong relationship, there's going to be more change. In this case, these two have come together. They've come closer together. We've actually reduced the amount of difference in the model because of that covariate. And let's look at the other example from our textbook. Our other example swaps these two outcome measures, swaps them and makes this 30 and makes this 50. And what we can see, I'll start with this at 0, is that group 1, the effect of 50, and the outcome of the mean for group 1 is 50, and the outcome of the mean for group 2 is 30. And when we put that adjustment in there, a full adjustment of 1, they spread out even further. Mean of group 1 goes further above to 55, and this one goes further down from 30 to 25. They spread out further and are distributed further. And it's because of the directionality of the covariate and its relationship to the outcome measure. Another way of thinking about this is whether or not we have a positive or negative relationship. So I'll go back to the original model we had, the original example we had, which was group 1 had a mean of 50 and group 2 had a mean of 30. So I'll go ahead and put the 0 in here, and we can just see there's a difference of 20 points between 50 here and 30 here. There's no adjustment. If we have a positive one, that is, the relationship between the covariate and the outcome measure is positive, then all these adjustments, we can see that group 1 being a 20 on the covariate and group 2 being a 10 on the covariate, the grand mean being 15 on the covariate, we can see where those adjustments occur. That is, 20 minus 15 is a negative value. So it's going to negatively impact our outcome measure. It's negatively impacting this by 5 points. And it's positive in this case. That is, individuals had lower scores on the covariate, relatively speaking. So if we remove that effect, their scores on their outcome measure should increase. So these folks had higher scores in group 1 on their covariate. These scores had lower on group 1 in their covariate. When we remove that effect, we end up seeing those converge. If this had been a negative relationship, we may also see a similar pattern to what we saw when we switched group 1s and groups 2. Now the negative relationship says when you remove the effect of this, it goes the opposite direction. Because, and that's just an artifact of the way Y1 and Y2 are set up. If we do the reverse on these, I'll go ahead and put that in as a 0 and reverse group 1 and group 2, we can see that at 0 we have 50 and 30. There is no impact of the covariate. When we have a positive 1, now they diverge, and that's simply because group 1 had a value of 30 and was lower than the value of 50 here. So they're spread out in space, but group 1 is lower than group 2. On the covariate, group 1 is higher than group 2. So when we remove those effects, they go in opposite directions. When we put a negative value here, they converge. And that's just to hopefully give you some thought behind this as you think through the idea of what statistical adjustment is. I'll certainly talk a little more of this about in class. I may post another video if there's time. And also, I will post for my students this simple Excel spreadsheet so that you can play around with this on your own time in Blackboard.